Hello, welcome to another episode of the Oxford MAT Livestream. My name's James, and today we're going to talk about algebra. Brilliant, good to have you with us. Hello to people watching in Slido live chat. I think I'm live. I think I pressed the button. Never really know with YouTube. It might just be me talking to myself in the office. Wouldn't be the first time. Here's Harriet and Rabil and someone with username Nikita Mazepin, Shizzy and Leonard Euler are in chat. Hi to everyone else who I've just been pre-live chatting to people over there as well. Hi to Prisma, who is moderating chat. Prisma's internet connection is not perfect, so if your chat message is delayed in getting approved, it's maybe because one or other of us has lost the internet. We will see. Somebody's just asked a very complicated AS level question, which I'm probably not going to be able to answer live because it's flying past in chat. That is my username backwards. Right, okay, not my username, my actual name, but backwards. Right, cool. You can set your name to anything you like in Slido. That's why we're using it instead of the Google-based kind of YouTube chat where you're encouraged to sign into your Google account, and I don't really need you to sign into a Google account. Anyway, enough about Google. How's your day, chat? You all right? How's it going? We had a bit of a weird one last week. I started the day at 2 stars, I think last time. I'm not at 2 star now. Behind the scenes, you can't see because it's behind this voting that's going on. I'm trying to find out how people's day are. Denim has just pointed out a mistake, and thank you, Denim. You picked a time. 2009 Math question 1F. Thank you. Right, okay. Maybe a 2 should maybe be a 3. Thanks, Denim. Just there we go. Good. AS revision. Yeah, good as me. Just got home 5 minutes ago. And then there's a crying emoji, which, hang on a minute, I'm going to turn the poll back on again, but let's have just a moment. Right, okay. There's this, like, crying emoji, which I've been told that Gen Z use as laughing. I've been told that you use that to mean, like, laughing so much that you're crying. Whereas for me, millennial, definitely means crying. So which changes the meaning a lot, right? Is it I just got home really sad because I haven't had a chance to do anything else before the math starts? Or is it just got home in time, hooray, happy? Someone says laughing, and someone says, yeah, right, cool, okay. Yeah, I knew about skull emoji. Someone's explaining, okay, this is now explaining emoji to James. Kai's got a suggestion that the other crying one, there is a crying with laughter emoji. This is the confusing thing for millennials. There is a crying for laughter emoji, but Gen Z refuse to use it. Yeah, in context, good, right, okay. Depends on context. I got to learn to infer context from chat comments, something like that. We've got a pretty strong peak on votes for 4 stars today with an average of 3.7, which is about all right. Carl Frederick Gauss in chat was doing substitute chemistry, and it all went wrong. I can never interpret the context there. Is always is Carl Frederick Gauss in character or not? Right, good. Okay, thanks for voting. I think as always, I'm looking at the 1 and 2 star people as well. I was one of you last week, and I did some maths and it got a bit better. Maybe that'll happen this time. There's a suggestion. Any tips to get better at geometry? Skull emoji. We did a geometry episode. I think the thing that people found really difficult in the geometry episodes that it's in your power to learn is that similar triangles, you can also do similar other shapes. You need to work out for yourself what that means. But similar rectangles might be a helpful thing for you to think about, or if you can spot some similar trapezia. That was the thing in the geometry question. This kind of idea about scaling things is more general than just triangles. I mean, you can make stuff out of triangles, so if it works for triangles, it probably works for other stuff. Good, right. Hi, Vert and Will, who's applying for CS. Cool, good to have some CS people here as well. And anyone else who's just around for some maths. We're doing, not this, we are doing some algebra today. The way this works is we go through a worksheet. The worksheet is also on the web somewhere out there on the Matt Livestream page. There's a link to this if you think it would be helpful for you to have a copy of it. Due to popular demand, we've now got the spaced out versions that appear on screen as well if you want to print it, but you also want to print lots of white space for writing things in, then that's now an option too. Right, shall I stop talking and start doing some maths? All of the reviews of this always say that I'm doing too much talking and not enough maths. Right, cool. I'm skipping the bit of revision material that is about solving simultaneous equations. I think you can solve simultaneous equations. If not, then hey, plug one into the other. Here's 2 sentences on screen about how to solve simultaneous equations. There's a point I want to really hammer home though, and I think this is slightly better if I say it out loud. I mean, it's in the notes, but I want to make a point of it as well. You need to be really careful with negative numbers and inequalities. Inequalities come into this section of the MAT Livestream, I guess, in the algebra section. You need to be really careful because there's this thing about multiplying by negative numbers. It's allowed, but you need to remember to flip the inequality. So maybe we start with like this true statement, -6 is less than -3. If you want to multiply both sides by -1/3, which is a sensible thing to do because it will get rid of these minus signs and it'll get rid of the common factor of 3, then the 1/3 bit doesn't cause any trouble, but the minus sign causes trouble. You need to remember to flip around the inequality sign as well. People generally, I think, accept that as like just one of those things, that when you're multiplying by -1, you've got to flip the inequality. But a mistake I've seen people make quite a lot is this kind of idea about squaring, because squaring feels very safe. Squaring, you're thinking positive, because all squares are positive. You're thinking, it's fine, it's just going to give me positive numbers, right? Unfortunately, squaring is sometimes like multiplying by negative numbers. There's an example down here where -2 is less than -1, but if you naively square both sides, you get 4 and you get 1, because it's a bit like multiplying the left by -2 and multiplying the right by -1. So this is one thing. So I gave this example of something that can go wrong, where if you square each side, oh no, we've got 4 and 1. But it's not just the case that you can remember to flip the inequality sign when you square, because of course that doesn't work on things like the fact that 1 is less than 3. We do really want to write down that 1 is less than 9 when we square both sides. So we can't have this rule of always remember to flip the sign when you square. That's not a rule because it's not true. We've got this kind of like these 2 cases that really seal the reconnect to the internet, which I have now done. We're back if you can hear me. Yep, we went really down there. It was my internet. I hope we're back. Let me know when I'm back. I'm just going to sit here and look at this maths until I'm back. Let me know if I'm back. Let me know if I'm back. Back again. People are saying back in chat. Good, that was quicker than I thought. Right, thanks. That might get edited. Sorry, that was me losing internet for a second. I think I was saying something like, hey, you got these inequalities, and if you multiply or square, then it's complicated. You might get the same numbers, but there's no simple rule of what to do on each side. And this is also a trick to get loads of engagement in chat by encouraging everybody who's watching to say the same thing at the same time, or the opposite of the thing. Right, good. Okay, if your audio and video out of sync, try reloading the stream. It should be coming to you at the same rate. I can't do anything about that on my end, but maybe if you reload the stream, we can get you back in sync, if that's you. Good, right, cool. Always find those moments are very disturbing, because from my point of view, nothing changes. Yeah, cool, right, good. If the Wi-Fi fails during an Oxford interview, we will do our best to reconnect and carry on. If we can't, we will reschedule. We only had to do this a tiny number of times. Somebody asks that every time I have internet trouble, which is very good fun. Good, okay. Choosing things as well, a binomial theorem. I wrote out the binomial theorem. If you would like the binomial theorem on a small bit of card, then you could print the MAT flashcards. It's really tiny. It's the MAT flashcard with the smallest writing. MAT flashcards available on the website in the bottom corner. It introduces as well this nice notation about binomial coefficients, which come up in choosing problems. So this thing here that appears in this expansion, this expansion includes these numbers. But those are also the numbers that appear in this choosing sort of problem. That's not a coincidence. Multiplying out this bracket is inherently something to do with choosing. You should maybe try and put that into words yourself about how, what's the relationship between choosing and multiplying out brackets, which is a helpful thing to think about if we're going to go and think about harder questions as well. We have not yet decided whether interviews for 2024 are online or not. That's 24 entry would be 23 if you're applying next year. We don't know. Will's using the cram. That's great. It was a bit of a work to get them onto the cram. I'm really glad that at least one person is using them. We don't get a counter. We don't know. It could be the case that nobody uses that resource that we built. We imported them all onto cram and then got them all to center. It didn't like one of the images. I really like how somebody says, "Don't worry, you're in sync," but they've said it like 10 minutes after the thing. So I'm in sync, but not necessarily with your time stream. There's at least 2 Mames genres in chat, which is a bit surprising. Slido doesn't enforce unique usernames, which anyway. There's an exercise here. This is a proof. People sometimes ask me if they're expected to memorize proofs or know proofs. I've put it on because I think you should see it. I think it's just good for you to see this proof. And I think it should probably make enough sense to you that you can remember it, so that if you had to, for any reason, if you had to come up with this again, then you wouldn't be able to recite it word for word, but you would be able to come up with the ideas of this. Kai says, what happens when n isn't a positive whole number? Kai, that is just the sort of question that lets me make the point that for MAT, we're only going to do the binomial theorem for positive whole numbers. At school, at some point, I hope that you learn what happens when n's not a positive whole number. I'm going to do it now just as a quick tangent for Kai, but it's it's not worth worrying about at this stage. This is not MAT, but Kai, look, if I write out those first few terms, n minus 1, where instead of writing out the choose things, I'm going to just write out these things. Plus dot dot dot. The rule is that if n's not a positive whole number, then I just keep going, and I write out these. Do I want the y's? I think I want 1s. Let's put y. I've had a sudden moment where I think I want x to be 1, just to make this a bit nicer. Yeah, let's make x 1. Simplifies everything. If x isn't 1, divide out. I think it's all true. I think what I wrote down might not have been wrong, but good. That is good. Okay. People normally write that as x, but I've been different. If I write this out, you will agree, I think, that this is the same thing as what's below. If n's not a positive whole number, then these coefficients never hit 0, so you keep generating more and more coefficients. That might sound a bit weird, but if y is a small number, then these terms get smaller and smaller, because they're powers of a small thing. So this only works if y is a kind of small number between -1 and 1. But if y is a small number, then this infinite series of terms is not too bad. It's a bit like the way that with the geometric series you can write down infinitely many terms and it's sort of fine. This is not a geometric series, but it's sort of fine. Okay. I find the change between orders matters and order doesn't matter a bit confusing. Yeah, it's to do with order. It's to do with a sort of symmetry breaking thing, actually. So, like, when you say order matters, people normally mean the ones that I've chosen. The order matters for those ones. There are different ways to think about that. People normally mean the ones I've chosen, the order matters. The ones I haven't chosen, the order doesn't matter. They're still in the box or whatever. And that's a kind of symmetry breaking thing, which makes the problem slightly less pretty in some way. I don't know. It means that this denominator down here prefers the n minus r factorial and doesn't have an r factorial in it. This is a terrible way of explaining it. I'm sorry. I'm just trying to give you a different way of explaining it to what people have seen before, or a different angle. I think it's important to know about, though. Quite good. Yeah, does the sum converge is just the sort of mathematician question that's just what a mathematician would say. Yeah, there you go. Anonymous person has answered it. Weirdly, due to time sinks, they've answered it before you asked it. But welcome to the out of sync non-linear time one. Jack's coming to the open day tomorrow. Sorry. Out of sync. There we go. I'm at the open day tomorrow. I'm doing my normal talk that I've done. How many times have I done it this year? I think I've done the Maths at Oxford talk at least 5 times already. Possibly 6. Yeah, at least 6 times. Is it 7? And I'm doing it twice again tomorrow. So we're doing the Maths at Oxford talk a couple more times. Good. Right. Order matters, order doesn't matter. There we go. Are we on warm-up questions? Oh yeah, we've got this binomial probabilities. I used to get loads of questions about this, and because we added binomial probabilities to the math syllabus, I used to get loads of questions about what that meant. But now we've got this math livestream resource, I can just point at this, say, that's what we meant by binomial probabilities. While people tell me that my internet's down, then my internet comes back again. What is going on? 1 2 1 2. Frozen again, and we wait for us to come back again. Funny livestream fail. Fine now, back. Yeah, that was a really quick one. I get a warning message, but there's not much. Just my internet dipping. I don't know what it is. I will look at some analytics afterwards. Oh, the viewership graph has a dip in it because people leave when it breaks. There's high stakes. What domain does the theorem, binomial theorem? It's a question of binomial theorem. Does it have to be a real number? And this is this classic chat thing about asking whether something's a complex number or not, or whether you could make it into a complex number. And, you could do that. Is my quality down to 144? Ah, refresh and try and get it back. We're broadcasting this in glorious 1080p, so I've been told sometimes that the sound works even if the stream stops. So I have to be really careful not to swear in anger when the stream breaks. We've only got 2 rules: don't swear and don't divide by 0. And if you think the stream's off, it's still on. Good. Right. You can change the quality even if it's defaulted. Here is some YouTube advice from everyone. MAT Livestream chat go. 1 session without mentioning complex numbers. Brackets impossible. Okay, we've got some challenges. We've got some warm-up problems before we get on to those lovely MAT questions. I put some simultaneous equations in. I really doubt that anybody watching is solving simultaneous equations for the first time when they see these questions. I don't think I want to do it live, but hey, for some reason, if you want to practice solving some simultaneous equations, there you go. I put a harder one in as well, where this first equation is quadratic. Does anybody know what sort of graph this is? I think there's something in the extension material or one of the extension materials. I saw a request there for question 10. Cool. I'm going to circle question 10 so I remember to talk about it. Oh yeah, we're definitely doing question 10. Does anybody know what this is on the left? It's got an x squared in and a y squared in. I can see circles in chat. Circles, yeah, something like circles. Yeah, it's actually an ellipse. This xy term, you don't know this at A level, don't worry. And you don't know this for math, but this xy term stretches things a bit. It's a little subtle little stretching effects, but that makes this an ellipse, which is like a stretched circle. Which direction is the ellipse stretched in is a complicated question. People in chat, ellipse takes slightly longer to type, so people are now saying ellipse. It's a little bit, is it weird? I don't think it's that weird. I think it's been translated as well. There's something going on. Anyway, okay. Not necessary to know this. Sorry if you can hear the background noise, by the way, of the building sites that has started up just next to my office. Anyway, you don't need to think any of that when you're solving this. Maybe if you're a really visual, geometry-based person, strongly Fantasia-based, then you can imagine this as an ellipse intersecting with a line or something, and we're pleased for you that you can find those two solutions maybe geometrically using some amazing knowledge of conic sections or something that Isaac Newton would have been all over. But for the rest of us, I think we'd probably write something like y is 2 minus x and plug it into the other one. So just be good to be aware that you've got these two things. What does the 5 indicate? Is that a Desmos? It's just a link to Desmos calculator. Somebody's linked to just Desmos. They were trying to share, I think, a Desmos plot of the thing on the left. We will see. You can ask about aphantasia. So someone sent me the exercise of learning about aphantasia quite a while ago, and I learnt a bit, but I want to learn more. There's some research papers I need to read. Good. The 5 is sort of, it's not quite, but sort of the radius. This is a slightly disguised ellipse, so we need to do a little bit of work. There's a technique that you learn at some point. So let's really not do that. Yeah, anyway, good. Right, there's a technique you learn at some point for writing that down in a format that looks more like an ellipse, more like an ellipse you know about. Do you know about ellipses? Maybe you don't know about ellipses. Not important. Why am I talking about ellipses? Good, right, okay. More solving. I quite like this one because I think it turns out to be good in some sense. It's like the intersection between geometry people. This is the intersection between two parabolas. This one is y equals 1 minus x squared. I've rearranged it. Y is 1 minus x squared. And this one is a bit of a weird parabola. This one is x equals 1 minus y squared, which I think is this parabola. But those are kind of quite nice similar parabolas. So you can get some intersection points just by spotting that 0, 1 and 1, 0 both work, I think. But there's some other stuff as well. Oh, hello. Loads of stuff in chat, sorry, that I haven't been paying attention to. Yeah, you have to put it. It's weirder than the x plus a squared. Equation of ellipse in general is like a ax plus by plus c squared plus big B dx plus ey plus f squared equals r squared or something. But that's not actually radius. But yeah, anyway, you've got a positive number over here on the right, so I've written r squared. And you can have x's and y's inside these brackets because of transformations. Don't try and think about this now, it's too many letters, too complicated. University, you'll learn a better way of dealing with these, promise. That's a mess. Yeah, it's a pain, sorry. Dan's asked about widening participation criteria. Free school meals, we don't guarantee an interview, we don't have a kind of, yes, no, what's the right word there? We don't have a kind of policy like that. We do take it into consideration. It's one of the reasons why we might look at people's math scores as well in the context of any information we've got about their school or personal situation. Reasonable math score I've read at the end of your thing, maybe. Nothing's guaranteed in life, but that's something we're interested in. Excited because we've now got a better source of free school meals data as well as self. Anyway, I'm getting off topic. Was I ever on topic? Okay, we're on inequalities. No, we're not. We're skipping these. I have quadratics again, but this time with inequalities. It's the same quadratic it always is on my question sheets. Do some expanding. Let's talk about 7 really quickly. Oh yeah, no, 6. Everyone always gets 6 wrong, so let's talk about 6. Can I have suggestions in chat? I mean, maybe you've looked at the solutions already. The solutions are on the same website, link down at the bottom. But be really interested to know if anybody made the same mistake that I'm kind of expecting. Yeah, cool. You mean that one? Draw the number line. Drawing a number line is a great idea. I'm always a fan. I think I'm always a fan of drawing pictures. If you want to, this is maybe A. This is maybe going to be a picture of A squared. Is this the number line you mean? Maybe not. Maybe I'm projecting an idea. What do I want? So this is like between -2 and 1. What's the range of A squared? Yeah, cool. Yeah, we're definitely not negative numbers. So there's a trap there, I suppose. Definitely not negative numbers. I guess the other bit of the trap, yeah, people in chat are putting something to do with 0 and something to do with 4, right? Because the minimum of this thing is attained at 0. Well, and it is attained actually. And then this is going to get all the way up to 4 on this side and only 1 over here. So I think that means that A squared is somewhere between 0 and 4. Now I'm being really pedantic here, I'm being really precise, that it could be 0, but it could not be 4. Which is maybe a little bit too pedantic, but I think it's true, that A could be 0. So A squared would then be exactly 0. So if your cases ruled that out, then note this kind of thing. If you said that 4 is between A squared and 1, then some inequalities need to be flipped there, and also surprise, A squared goes outside of the range. Geometrically, do you want the geometric? I could say something. Let's focus. Everyone wrote something pretty plausible and pretty close. I want to say something slightly weird. That this is like taking a piece of string or something and folding it over, not with the ends lined up, but folding it over with the ends not lined up. If I got like a cable or something. No, okay. Anyway, take a bit of string and fold it over. Then the ends are very frayed. If the ends are very frayed and don't quite exist, then you get this kind of frayed end at the top. But at the other end, where it's folded over, you don't get a frayed end. You get a kind of normal bit of string. And that's sort of what's going on here. It's being the number line's being deformed like this, and it's got the frayed end at the top. The other frayed end doesn't matter, and then it's got a solid bit of string at the bottom. That kind of deformation and transformation is maybe not a helpful thing for you to think about right now, but it's an alternative way of looking at what's going on with this transformation to the number line. Good. How do you know the minimum is 0 and not 1? Well, I can think of an example that A could be 1/2, in which case A squared is 1/4. 1/4 is less than 1, so it's not true that 1. It's not necessarily true that a squared is between 1 and 4. Just like it's not necessarily true that a squared is between 3 and 4, right? There are other cases that we need to think about, like a being somewhere around here. Okay, I really like this question. I think it's fun. As an extension, I think I would like you to try. Now you can make up your own extension or your own version. If this question caught you out, then I would like you to think about. Gosh, what do I want you to think about? Something like a is between -2 and 1 still. What can you say about? I want to say something about a to the 4 minus a squared. Okay, that made up. Question 6.5. On the spot, don't really know how hard it is. Sorry, haven't tried it. But I've got a feeling that you might enjoy thinking about this as a slightly different question. Good, okay. Right, okay. Question 7 is a bit of a discussion question. The answer to the first bit is this trick about like multiplying. Multiplying these equations is sort of even worse than squaring. Multiplying inequalities together is even worse than squaring, because if the equations are the same, then it is squaring. You've got a squared and you've got b squared if c is a and d is b. This is worse because, hey, maybe these equations are not the same equation, so it's much more complicated. You can't say anything really about what's going on when you square things. It'd be really nice if AC was always less than BD. That's not true. It'd be really nice if AC was always bigger than BD. That's not true. If you're told that everything's positive, and by the way, if A and C are both positive, then so are B and D because they're bigger. If you're told that everything's positive, then it's all fine. You can multiply together. You know that AC is less than BD, which is probably what you want to write down. Yeah. So at first it says nothing, but then if you find out that everything's positive, if you restrict yourself to staying positive, then everything makes loads more sense. Good. It's 45 predicted IB. 45 predicted IB is top marks, I think. I don't know if it's actually equivalent to anything in the A-level system, because the A-level system doesn't really have that kind of concept of doing everything like that. Like that 45. I don't really know. Tracks across. Yes, Chris. Am I down again? Oh no, that's an old chat message. Good, cool. Okay, so to start off with, nothing, nada, and then later, begrudgingly, we'll admit that in this case, AC is less than BD. We're multiplying each side by a positive number, so the signs don't change, and then you can talk about how big things are. People are often doing my other questions, so that's good. That's the number 240. Ooh, SV, careful. So SV's got some pretty complicated numbers at the top here. SV, have you considered the number 0? The number 0 is in the range, and ooh. Oh wait, no, your range has got a minus quarter in it. Sorry, I take it back. Sorry, I thought I was being clever. I was not being clever, I was being an idiot. Flipping coins is a binomial thing. Checking that these add up is, I think this is fun, kind of geometric series kind of thing. So if you want a geometric series, then here's one of them. No, it's not a geometric series, is it? Sorry, it's the binomial expansion. Still think this is fun. Can't remember what it is, but hey, binomial probabilities, binomial expansion, they're precisely the things that you get out of the expansion. And if P and Q add up to 1, then that thing over on the left, the sum turns out to be this. Proper solution with actual working out and true facts in it on the website. Good. Is the answer? I'm not going to answer questions like, is the answer? Some numbers. This question is looking harder than I thought, because the numbers people are putting in chat, are very complicated. Sorry chat, I've made you do a hard problem. And then moved on immediately. Right. Question 10. By request. Not as much as 240 maybe only 12. A squared is less than 12. I think it is less than 12. I don't see how it could get bigger than 12. Because, yeah, anyway. I'm distracting myself by trying to do the question now. Chat, I've ruined everything. This question says that I've got 6 cards, and it's not a lie. I do have 6 cards, here they are. They've got the numbers 1 to 6 on them. And the question says, let's get that out of the way. The question says, I'm going to shuffle them and deal them out. What's the probability that the first 3 cards I see are all prime numbers? I thought it'd be fun to do this. maybe this is a bit of primary school, I don't know. Somehow they're having the big block writing. Sorry if this is childish. Maybe this is really patronising. Never know, right? How to pitch it's the colour as well. I should have chosen a more grown-up colour. Right, okay. We're going to try and draw 3 prime numbers. So I like my odds to start off with. There are 6 cards. Prime numbers are 2, 3 and 5. So I think it's 50-50 that the first card I see is a prime number. Let's try flipping it over. 2, yeah, okay, that is a prime number. I've been lucky. So write that down, everyone. I was 50-50 on this first card. This is my first attempt. Not too bad. 3 possibilities up 6. I got lucky, maybe hit that 50-50. Got a prime number. For the next one, I know that there are 2 prime numbers somewhere in here. Quick note, I know there are 2 in here because I was successful on the first one. I know there's 3 total, 2 and 3 and 5. So there's 2 left. If I'd been unsuccessful, there would still be 3. There are 2. I don't know where they are, but I know how many there are. Oh, maths, eh? We're going to try and flip this. Let's see if I can pull this off. So the probability this time that I'm successful on my second draw is, I think, 2 out of 5, given that I was successful on my first draw. Ah, 3! Brilliant, okay. Oh, I hit another prime number. So this is going really well. I've got 4 cards left, and this feels a bit more dicey because I've only got 1 prime. What are the chances I've been successful so far? I suppose there was a 50-50 on the first one, and then if I'm successful on the first one, there's a 2 out of 5 chance on the next one. So overall, that's you multiply together for successive things where you want both to happen. So 1/2 times 2/5. I think the thing we've seen had a probability of 1 in 5 to happen before we went live. 20%. We pulled it off. So this is already in the top 20% of live streams. All the parallel universes that are running this live stream as well. 80% of them have not got this far. Can I flip over the number 5 card? I hope you agree that's a 1 in 4 chance, which brings us to a total of 1 in 20. No! I've hit the 4 card. Was this it? No, that's the 6. Oh, it's somewhere in there. Right, cool. Good. Hopefully that was over-explained. Ah, dear. I just thought it'd be fun to have the cards. Right, I'll just chat. Oh, yeah, okay. 100% of you mark the cards. Anybody else have? Girolamo Cardano, who did some cubic equation stuff and is a good card name for right now. Really hope it's 5. Yeah, me too. I really thought it'd be good. It's not like that time I rigged all of those coin flips, but didn't actually rig the coin flips. Good. Right. Okay. Was there a hard one? Oh yes, there's this hard part as well, but probability that they alternate between odd and even numbers. I actually think this one is easiest to think about if you imagine permuting the cards, so like shuffling the cards but face up to think about what could happen. Let's look at the cards once more just for this alternating between odd and even numbers thing. There's a question about dealing all 6 of them out. Let's have a quick look at the cards again. So if I put the cards out in order, I'm going to deal them, maybe they alternate or maybe they don't. Playing with the cards, there's sort of 2 different classes of ways that they can alternate. If I start with an odd number, then I've got to go odd, even, odd, even, odd, even. And if I start with an even number, I've got to go even, odd, even, odd, even, odd, like that, I suppose, left to right. But within that, I'm pretty sort of agnostic about which odd number is which and which even number is which. So within my first category, where the odd number comes out first, I suppose I've got 6 permutations of this top row and 6 permutations of this bottom row. So 36 possibilities altogether. And then I've got another 36 possibilities in my second category, where I start with an even number. So overall, that's 72 possibilities. Those are all the ones I like, where it alternates, 72 possibilities. How many are there in total? Well, there are, in general, 6 factorial ways to mix up the cards, which is 720. So I'm looking at 72 out of 720, which is 1 in 10. And I think sometimes, like this example, it's easier to just sort of count how many work and count how many there are, do the fraction like that. When you deal out these 6 cards, you see one of a huge number of possibilities, one of 720 different things, but we can put those things into categories and work systematically, and sometimes that's just better. I think that minus 1/4 less than A less than 12 is close but not quite. It's got some thumbs ups. Close but not quite. Right. I never thought I would have to face off against my own personal statement, but my own personal statement has just joined live chat to say 1 in 30, which is not quite true. 1 in 10, I think. Shall I let you do this in the question? Yeah, either starting with an odd number or an even number, and switching between odd and even for each other. The alternate way to do this question about alternating numbers is to think about the probability tree, I suppose. So first card could be anything. Anything, 6 out of 6 possibilities. It's going well so far. 1 card comes out. Yep, cool. That could be an alternating sequence. And then there's 3 of the opposite parity out of the remaining 5. And then 2. Oh, goodness me, it's a bit harder, right? To actually work out what's going on as you go through the possibilities on the way down. And that last one has to work. And that works out to be, 18, 36, 72 out of 720. Phew! 1 over 10. Okay, so there's an alternate way to write down that sequence of things that need to happen. Okay. Yeah, there it is in chat with the pi username. Or is it pi with exactly 1 digit wrong? No, let's not look at it. Okay. So we had this question, first 3 cards to deal out are all prime numbers, and that's like getting all of the primes. I think that was 1 in 20, and 20. And along the way we discovered that just the first 2 are sort of 1 in 5. You can think of that as the events strung together, or you can think about it by shuffling things together. In this particular one, the shuffling is a bit difficult to think about, but I think it is possible. And then the last one is just a little joke. What's the probability that the first 5 cards I see are prime numbers? That is 0, because there aren't enough prime numbers. Ha 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 ha. Just a little joke. But it's a sort of serious point, I suppose, that if you write down any probabilities multiplied together, then you missed a trick. And in some sense, noticing that these questions might be easy or they might be hard. When you see them, you don't really know. I think it's important that you see at least some questions in your life that are too easy for you, because if you want to go on and do sort of research mathematics, or if you want to solve people's problems from the real world, maybe you're trying to solve something to make a business work better or something, I don't know, then you don't really know when the problem lands in your inbox whether it's a hard problem or an easy problem, and sometimes it'll have a stupid answer. Good. Keeping up to speed in math is pretty hard. It's not a very long time, it's 2.5 hours. You probably won't have time to do absolutely everything to the kind of perfect standard that you might do an A-level paper to. I'm sorry about that. I think we asked people once if you imagined your score kind of goes up with time, right? Because you do stuff. And if you had all day, maybe it's diminishing returns because you're getting closer to levelling off now. But I don't want to give you all day because that sounds awful. Good. Oh my goodness, someone's trying to break Slido. If you break Slido, oh my goodness. Oh no. Right, okay. Those are the warm-up questions. How are we doing for time? We're doing all right for time. Should we do some math questions? We've got a question on inequalities, a question on graphs that involves algebra secretly. Not a very good secret, it's the Algebra livestream. A question about multiplying out a thing that's in the thumbnail, and a long question which I quite like. What should we do first, chat? I think somebody asked. Good. Somebody asked if I was senior wrangler, and the answer is sadly no. Good, okay. I haven't got any preferences. Do them in order. Pi. Graph 1, multiple choice. Long question first. Long question, that's 2. Voting for long question. Long question before a tangent. This is your first live stream, but so someone. Good. Pictures. Okay, right, we're doing pictures, then the long question. Hang on. Sequence. If this sequence annoys you, then try and time. You're allowed to leave the live stream, but then time your return. We got to do the thumbnail, and then we'll go over here. We'll do this one. I think that's the sequence. Nobody seems that. People do want to do them in order. People do want the live streams. Somebody said that it was the first live stream, but then they got censored because of their username. Good. Please don't swear, and please don't divide by 0. If you feel like swearing, please type. This person's got my name backwards. It's very confusing. Anyway, right. We're doing this one first. it's just happening. It's a sketch of a graph, and we're going to switch on a poll for voting for it. I think I've got a poll for this. Yes, I do. It's an invisible poll. You can't see what other people are voting for. We're going to start talking about the question and see if that helps people do the question. Multiple choice, eh? This is back from 2013, where we only have 4 options on multiple choice. We went up to 5 to make guessing slightly less good, but guessing is still better than nothing. So if you don't know, guess. There we go. Righty-ho. Okay. I really like a good bit of algebra in one of these questions as well. There's some rearranging you can do. There's a hint on the screen as well, which is not printed in the original math question, but we've added for today. I think rearranging it is fun here. You've got 2 different approaches, I think. First thing I saw just now, with fresh eyes on this question, is that the left-hand side is the difference of 2 squares. It's like x squared minus y times x squared plus y, which makes me think about parabolas. Unfortunately, the right-hand side is 2y plus 1. I don't really know what to do with that. Makes me feel like I don't know how to factorise the right-hand side, so I don't know. There is a suggestion in chat to plug special numbers into it, which is great. I love these. These ideas are much better than my ideas. Anyway, so credit to behind the poll at the moment. Person with the username Nikita Mazepin, Will, Raphael, SV also wants to set x equals 0. Sounds like chat's telling me that x equals 0 gives some sort of speedy route to the answer. If I put in x equals 0, I get minus y squared is 2y plus 1, 0 equals y squared plus 2y plus 1. I'm rearranging. I can recognise that. So I'm sort of factorising there to write it as y plus 1 all squared, but of course sort of also spotting it, recognising it. I've multiplied out this square at the bottom so many times that when I see y squared plus 2y plus 1, I'm already thinking this thing at the bottom. I'm not trying to show off, I'm just trying to tell you what I'm doing. Oh, I see. So then that's only y equals minus 1, and that's b. Only, right, okay. I see why chat's told me to put x equals 0 in. Very good strategy, chat. Very impressive. Chat also wanted me to try y equals 0. Should we try y equals 0? Y equals 0 kills off loads of these terms, but it gives me x is plus or minus 1, which could be B, C, or D. Okay, so it's a good idea, but not perfect. Yeah, and Hugh in chat, and I think actually Kai as well. You can do this. You can get rid of the plus 1 in several different ways. One of them is to rearrange first. So rather than doing this, which is valid, it's true, but not helpful, is to rearrange it to y squared plus 2y plus 1, and then use the fact that that's y plus 1 squared. Be really careful with the square roots to say that x squared is y plus 1, or x squared is minus y minus 1. There's a minus sign from the square root. These quadratics, goodness me, these quadratics, have I got my plus 1s right? Yeah, these quadratics both go through, right, okay. These quadratics both go through 0, minus 1. One of them is a happy quadratic and one of them is a sad quadratic. Let's write them out. Y is 1 minus x minus 1 minus x squared, and this one is y is minus 1 plus x squared. Cool. So up and down. So this one is pretty close, but you've missed, I think, a minus sign on your 1. I think this is minus 1 minus x squared. No, I think this is 1 minus x squared and minus 1 plus x squared. So don't forget you get a minus sign on, as well as the y, you get a minus sign on the 1. Yeah, something like that. Good. Right, cool. Quick look. Yeah, we got a 95% on B and a little bit 5% on D, which cool, lines up with what I kind of thought. Loads of votes on that one. Thank you for joining in. Immediately read the question wrong. Let's try and read the questions correctly. Let's try and get through there. Right, good. Okay. What am I doing next? That was the plan. That was a really quick one. I liked that. I like the way, so hindsight, looking back at the question, I should have thought of plugging in x equals 0. It didn't need to be necessarily that good. So this is quite good. Did it just immediately go as B? But plugging in x equals 0 was, I think in general, quite a nice idea for this sort of thing. Yeah, okay, I should do that more. Right, cool. Okay, I've learned not to do this. Oh, correct, so assume the graph is not symmetrical because of the 2y term. About the x-axis. Let me think about the x-axis. So the x-axis would be replacing the y's with minus y's. That's how you do a reflection in the x-axis. Everywhere you see a y, you replace it with a minus y. And I think you're correct that the y squared will stay the same, but the 2y will flip. The 1 will stay the same, and that means it's a different graph when you flip it in the x-axis. Oh, I see. And you're saying that because that solves the question, because A, C, and D all have that symmetry, and B doesn't. So you're noticing that the flipping symmetry, where you flip it in the x-axis, doesn't preserve the graph. That's neat. I like that. Have we got any more approaches? Rooting both sides is a bit tricksy. You prefer to do difference to two squares. Oh yeah, okay. So difference to two squares. If you want to do that, I guess we tried difference to two squares up here, but down here, if you bring the y plus 1 squared onto the left, now you can difference to two squares it, and you get a 0 on the right hand side because you just put a 0 on the right hand side. It's equivalent to taking the square root, but I can see how you might prefer this as a way of dealing with it if you're unhappy about square roots. Guessing is a very good strategy. Well, not very good. Guessing is about a 20% strategy. But hey, earlier in the live stream we had a 20% success chance to flip those two prime numbers, and then we did. So sometimes 20% things happen. Right, good. That came across too motivational. Well, let's do the long question. Flying through it, we're doing great. 45, we haven't even hit 6 o'clock yet. We're going to do a long question before 6 o'clock. Let's just go for it. Matt Schools for Computer Science, they put some stats on their website. Somebody linked to the website? I'm going to link to the website because I've got it bookmarked, I think. No, I don't. Never mind. Ignore me. Somewhere on the Computer Science website, if you dig through the CS website, it's a very good website because it's the Computer Science department. They've got statistics about things like that. Right, I'm going to put the question on the screen and answer that question. Why does CS not use their own test? They sort of do, in that question 7 on the test is only taken by computer scientists. So in a way, question 7 on the MAT is the computer science test. I mean, they also do all of the multiple choice questions. I'm saying they, you possibly at home, hey, computer science applicants, you do a slightly different version of the test because you're doing different questions. Got some overlap, which is, I think, very sensible. Hey, someone's making fun of me for saying sometimes 20% chance things happen, but I was proud of that as a link, if nothing else, between the 1 in 5 chance of getting a multiple choice question correct on the MAT and the 1 in 5 chance of drawing 2 prime numbers out of cards marked 1 to 6. Here's an algebra question with nothing to do with drawing cards or probabilities. Let's not guess the answer. It's got a show that in it. If it's your first live stream, I'm a big fan of show that questions, I think. Ones where we get to explain why something's true. We're not going to get much credit here just for stating that A of B of X is the same thing as B of A of X, because that's in the question. Everybody's working out for this is going to end up with A of B of X equals B of A of X, no matter whether they understand it or not. The trick here to get the marks is to show it, to explain why it's true, to write down anything else that's not exactly this that helps to explain why it's true. So for example, you might write down the helpful true fact that A of B of X itself is equal to 2 times 3x plus 2 plus 1, which is equal to, and then we can do some maths, right? 6x plus 5. Pretty good. And you might also work out B of A of X, and then conclude that these things are the same. I'm going to do it because it's easy, and I feel like if I do the easy parts, that makes it easier for me to skip the hard parts. Cool, okay. So these functions, they do this nice thing. Extension that you should think of, but not do immediately. You should think of the extensions yourself, right? But not immediately do them because we're busy doing a math question and we should not get distracted. But does this always work when you're given two functions like this? A of X and B of X. Can you always swap them? It'd be good if it was true, right? Can you always swap the functions? Do you see linear things like this? Seems too good to be true, right? But hey, maybe it works. People in chat are not convinced. They think this is not a good idea. Raphael, I really want to do this question. Right, Raphael's suggestion. I'm getting distracted. Matt question about the chances of guessing a certain number of multiple choice questions is a bit hard because the grid is quite complicated. Well, it's not complicated, it's a grid, but there's a really hard probability question you could do where someone ticks 10 boxes at random out of the 50 boxes. and they might have 2 ticks in the same row, or they might not. It's really impossibly difficult to work out what their average score is. But that's the kind of natural question that you would ask about. If you were doing a meta question about randomly answering math questions, you'd say, put 10 ticks on the box. Don't pay attention to whether you're ticking the same row twice or not. What's the expected score? Anyway, some things that I've already thought about, but too much. You get no marks if you tick 2 boxes. You don't get marks. If you tick no boxes, you don't get marks. So it's a tricky question, because that could happen. You could tick 3 boxes under this random thing. Please don't clip the phrase "you could clip 3 boxes." Oh, look, it's the official MAT countdown. Unofficial, right? It was. I swear it was unofficial last week. Anyway, right, sorry. You can't always commute functions, but these ones are nice. Let's remember this, because I feel like it's necessary later on, but we'll get there. We've been asked to apply a n times, and there's an answer in chat from Nikita Mazepin. Yeah, some powers of 2 going on, right? I think there's a geometric sequence. This is just a's, a of x. I think there's a geometric thing going on. I think it's quite nice. So this is 2 times a n minus 1 of x plus 1. So you apply it one more time, and it doubles things up. I suppose I want to work out some of the first ones. Like a1x is just x. Oh my goodness. a1x is just a, which is 2x plus 1. A squared, a2x, what are we calling these? A squared maybe? I don't like calling it a squared because it's not like how cos squared works. Maybe I've overthought it. I think that's 4x plus 3. Oh, I see, okay, and then the next one is 8x plus 6 plus another one is 8x plus 7. I've got a strong feeling that this is 2 to the n x plus 2 to the n minus 1. And there's a geometric series going on for why it works. It is unofficial. Thank you for the disclaimer. We do mental health, but I think Prisma knows that I get distracted very easily, and sometimes Prisma's trying to help by not moderating out things. Anyway, is it nice in binary? Depends how you feel about binary. Yes. Oh, so someone's got this answer. An anonymous person. I'd forgotten about anonymous people. Where are you at? Hi, anonymous people. Sorry, everyone seems to have chosen a mathematician recently. So I think you can be anonymous in Slido chat. That's another reason we're using Slido chat. They've said that 2 times 2x plus 1 plus the sum of 2 to the n for r is 1 to the n plus 1. That sum that you've got there is a geometric sequence. First episode of Oxford MAT Livestream this year, we talked about a geometric series. You can do that sum. You'll be alright. Good. And I think your first term you mean like 2 to the n x or something like that. Yeah, good to me. Okay, good. Maybe that's a multiplied sign. Not quite sure. Is that good in binary? You've got me worried now. There's all loads of 1s in binary, right? X times some number with loads of zeros in. I don't know. What counts as nice in binary? Anyway, here's a function. 108x plus c. C is a positive integer. It's produced by repeatedly applying the functions a and b in some order. So I think this is trying to describe the idea that you might have a of b of a of whatever, who knows, for some stuff, repeatedly. And the idea is that you apply functions either a or b loads of times, repeatedly, and that's supposed to be equal to 108x plus c. And then there's a question, how many different orders can a and b be applied to produce f of x? Which is mad because I can't think of any at the moment. Anonymous is still here, good. Anonymous checking in, that's pretty good. Our first few examples, it could have been plus 1. Kind of worked out the next one as well, which is... This could have been, it could have been 1 more than 0. That's 1 more than... Could it have been 2 to the n plus 1? It could have been 2 to the n plus 1. I've only got the numbers 1 and 3. You're right, I was extrapolating from some dodgy data, I suppose. I was expecting something like... what am I expecting? 2 to the n. I suppose I could write this out with more brackets and 2's, if you like. It's not a very complicated thing. It's like 2 times 2 times 2 times ... plus 1 plus 1 plus 1. And then inside here, there's an x right down at the bottom. And it's multiplied by 2 n times. And the other terms that we've got around, 2 2x plus 1 down here. The other terms that we've got around are ones that are multiplied by different numbers of 2's. There's one right in the middle that gets multiplied by all 2 to the m minus 1 2's. And there's one on the outside that doesn't get multiplied by any 2's. And that all adds up as a geometric sequence. Good, okay. We're trying to make f of x. I think people in chat have pointed out, yeah, you need a couple of a's and a couple of b's, I think. Is it that many? Is it 2 a's and 2 b's? Maybe 2 a's and 3 b's. Let's find out. So this coefficient of x, we don't know what c is, but we know this coefficient of x is 108. I think it's been made out of a's and b's, so that coefficient of x, I think what we've seen by multiplying all these, applying all these a's together is you get this kind of 2 to the n thing. There's 2's coming out the front on the coefficient of x. Maybe if we get some b's involved, then we get numbers like 6, where we get 2's and 3's. The previous parts of the question are sort of building our intuition about what's going on there, helping us by getting us to do calculations that are relevant later on, by getting us to explore how we apply these things. We made a 6, we made some powers of 2, what else can we can make 108. 108 is equal to, goodness me, prime decomposition in here. 2 times 54. 54 is 2 times 27, so it's 2 squared times 3 cubed. It's one of those rare moments where knowing a few cubed numbers was a bit helpful. Good, so we're going to need a to be applied twice, and b to be applied 3 times. It's not obvious to me what this question really means. I mean, I don't know what c is. It's going to turn out in the next part that I sort of do know what c is. I'm going to work it out when it says what are the possible values of c. Around here, though, I'm a little bit worried that if these give different values of c, are they really giving f of x? Are they giving the f of x we were thinking about in the question? Maybe not. This is a hang-up that is not actually justified, because it turns out all of these combinations give you the same function that is f of x. But I'm a little bit worried that, some of the combinations maybe give me different things. Do you have to prove your answer to 2 or just find an expression? That's generated discussion. Let's quickly have a quick look at that discussion. It does say, it says determine as simplest form. I reckon there's only a couple of marks on part 2. I would probably explain it a bit, or at least include my working out. Including your working out is good, even if you're not sure you're going to get any marks for it. Including your working out is good because maybe you get marks for it. If you make a mistake, but some of your working out shows promise, then or shows that you're on the right idea. Anyway, we've got 2 a's and 3 b's, so we've got to do some sequence of those. There are quite a few of these. It's like shuffling 5 cards that say A, B, B, B. We're going to apply 5 functions. 3 of them are b's, so there's 5 choose 3 permutations of these things, which is, the same thing as 5 choose 2, which is 10. 10, yeah. Part 4 is sort of brilliant and magic. Yeah, working out isn't really good. The pattern is obvious. Do I get the marks for? Do I get my marks for just listing the first 3 and then writing down this, which is what I did? Would I give myself the marks for that? Yeah, probably. Yeah. This question's from before I was in the job, so I don't know how it was marked, but yeah, I'd give myself the marks for that. Good. A, B, B, B. Oh, okay. It looks a bit like C is, so someone in chat says constant is always 1 less than the coefficient of x. That's consistent with things we've seen so far. Let's circle some constants and point out how they are 1 less than the constant coefficient of x. That's true here and here and here. It's true here, it's true here, it's true here, and of course it's true here as well. So it's true so far, but of course that's not proof. Maybe we should think about proving this. This bit says justify your answer, so we are going to try and explain what's going on here. Let's have a quick idea that okay, so maybe we think that anything made from A's and B's is of the form kx plus k minus 1, and then the proof of that, if it's true, if it's false, then this proof will fail, and I'll just scribble it all out and I'll do something different. But I like to be assertive and just start writing it. You know, in an exam I'm in a hurry, so I'm pretty sure this looks a bit true. I'm just going to try and prove it. If it goes wrong, I'll just scribble it out and pretend this never happened. Lose the internet mysteriously, just that moment. Never see me again. Proof, a of x and b of x themselves satisfy this. And then if we apply a or b to kx plus k minus 1, so I'm using algebra here, maybe that's the same k as this one, maybe not, doesn't really matter. If we apply a or b to make something new, talking is so much faster than writing. If we apply a or b, we get, then we get 2 kx plus k minus 1, which is 2kx plus 2k minus 2, adding 1 because that's how a works, which is 2kx plus 2k minus 1. That looks good. Or if we apply b to something of that form, then we get 3kx plus 3k minus 3 plus 2 minus 3 plus 2, which is 3kx plus 3k minus 1. Still of that form. So C must be 107. I really like this, actually. I think this is kind of slick. I don't actually have to work anything. I don't actually have to calculate a of b of b of b of x. Doing this different thing. Cool. Okay. Can I explain what's 5 choose 3? Someone 2 thumbs ups in the chat. Chat's helped out. I love it when chat answers each other's questions in a helpful way. There are 5 terms. 3 of them are B's, so it's 5 choose 3. You could look at it in terms of A's as well and say that it's 5 choose 2, where there are 5 functions I'm going to apply. It doesn't matter what order, I'm going to get 108x plus something. Doesn't matter what order. And if you mix them around, well, how many ways are there different? Well, okay, just choose which 2 are the A's. Maybe it's the first 2, maybe it's the last 2, maybe it's the middle 2. Well, what do you mean the middle 2? Oh, right, first pick one of the A's, pick a different A. It doesn't matter which order you picked the A's in, because you're just pointing at them. Pointing at the first 2 out of order doesn't count as different. So divide by 2. So 5 times 4 divided by 2. That's called 5 choose 2. And that choosing step, which is quite a lot of mental loads, is just a thing that people go. They've just put a reminder to stay hydrated. Did somebody put a reminder in? Oh, good. We just hit 6 o'clock. Remember to drink some water. Thanks. I'm going to do that too. Thanks, Brisbane. Cheers. Right, okay, so C is 107. It's pretty cool, actually, that we can solve that without thinking about that. It's like induction backwards. I think it's... I'm trying not to use the word induction because not everybody knows what that is. This is laid out like a proof by induction. I can't really help it because once you've learnt about proof by induction, you start laying things out like a proof by induction, I suppose. It's sort of backwards a bit. I'm also sort of going a bit forwards. But I hope it makes sense, even if you haven't seen proof by induction, that what I'm trying to do is check that if you only apply one function, just A or just B, well, that's in the right quiet form. If you're making 2 functions put together, like an AB or a BA, I can work both of them out. In fact, we already did work out both of them. But in general, like I say, all you're doing is you're applying an A or a B to something I've already seen. And the things I've already seen, they're all safe, they're all good. So now if I want to think about things where I apply 3 functions, A or B or A 3 times, A or B, A or B, A or B, there's like 8 possibilities. I don't want to work them all out. This says that all we need to do is think about what happens when you apply that last A or B, apply that to things we've already seen. Forbidden knowledge. Right, good, okay. We've got one part of this question left. Doing great for time. Don't really know what we're going to do in the second half. We'll get there when we get there. We've got a couple of multiple choice questions left. Maybe we'll talk about the extension or ellipses or something. Binomial expansions. Goodness me. These notes are available later. Great news. These notes are available now on the MAT Live website, along with the ones from next week and the week after, and the last 5 weeks or however long we've been doing this. Yeah, good. Okay. The notes that I'm writing live are available in this YouTube video on YouTube, but depending on whether YouTube messes this up or not. I think YouTube's saving it as we go along. Good times. Last part's got a lot of reading in. Not going to lie, there are a lot of positive whole numbers suddenly. There's this whole sequence of m's and the sequence of n's. I'm going to zoom in so we can have a quick look at the m's and n's. There they are. These ones are in a little sequence, look. M1, haven't shown us very many of them, but there's an M2, M3, all the way up to MK. And there's a sequence of n's. People usually use m's and n's for integers. I'm not entirely sure why. Such that, which means they're the ones that satisfy this equation. Oh my goodness. These are like the powers of applying a function lots of times, right? And look at this. This is a superscript, a small number up high, which itself is wearing a subscript number, which is a number down low. So this 1 is kind of living in this sort of no man's land. It's lower than a high up thing, but it's kind of not lined up with the superscripts and subscripts. Got them all going on in here. Anyway, we've got k of these. I suppose k is also an integer. I suppose k is also an integer. And we're going to add these together. Oh, goodness me. Add together these different functions. Right, my word. Leo says that these terms in the sequence have to be a multiple of 6. I suppose they're a multiple of 6 if they've got an a and a b in them somewhere. Oh yeah, that's true, isn't it? And they're positive integers. 0 is not positive. So this would be a multiple of, the coefficient of x would be a multiple of 6. I agree with Leo. Coefficient would be a multiple of 6, and then the coefficient of x would still be a multiple of 6 after adding them up. This is big brain. But this thing over here is not a multiple of 6. Ah, that's pretty clever. Pretty good. I like that. SV's got a substitution. I got told off last time for doing too many substitutions. Or was it the one before? I did a load of substitutions and people didn't like it. So I'm not substituting for this one. We will see. Yeah, that's pretty good. Maxing the coefficients of x. Are we maxing the coefficients of x? What do you mean maxing them? Nikita Mazepin's trying to factorise it, but be careful because these things on the left might be different. So it might be that sum is, because there's adding. Combining together adding and prime factors is pretty messy in general. I think I can make complicated things by adding together these. For example, we already had stuff like 6x plus 5. And we already had, so maybe this is 6x plus 5, maybe this is 108x plus 7. So we can make something like 114x plus 12, which is pretty, I mean, it's not close at all, but it doesn't look unlike the thing on the right hand side. And importantly, like the factorization of 114 is not really relevant. No spoilers, just straight in with this multiple of 6. Actually Leo said it a while ago as well. Ooh. Anonymous is plugging in x equals 1. What happens if you plug in x equals 1? It's not a substitution, we're just plugging in a number. X equals 1. So they've told me that if you plug in x equals 1, well then a would be 3. So every a would be, oh no, I don't know how to. Plugging in x equals 1 is quite hard because a of 1 is 3, but if it's like a of 1, then I've got to plug 3 into this equation as well. Again, I'll start getting this power of 2 stuff. A of minus 1. This is now we're thinking about cheating and plugging in a of minus 1. If I plug in x equals minus 1, which is the suggestion that sort of SV gave. Did you say minus 1 in chat? Yeah, okay. They're talking about multiples of 6 in chat as well. So alternative approach, plug in x equals minus 1. I've got a feeling that's nice. Yeah. Let me show you what happens if you plug in x as minus 1. A of x is 1. Excuse me. Minus 1. That was an embarrassingly long pause. B of x is minus 1. Right, okay. So it doesn't matter which one you apply. Okay, they agree at the number minus 1. So you can maybe discover this by setting them equal to each other. They agree when x is minus 1. minus 1's a kind of fixed point of both of these functions. So that means that no matter how many a's and b's you put over here, if you plug in minus 1, you get minus 1 out. So on the left, there are k terms. When I plug in x is minus 1, I'm going to get negative k on the left-hand side, and on the right, I'm going to get negative 100 and something. This is a advanced strategy that I'm not very enthusiastic about, I have to admit. I think it's a bit out of the spirit of the question. This is minus 122. I'm having trouble subtracting as well. Be nice. How do I subtract 214 from 92, chat? Minus 122. Just got to believe in myself, right? Yeah, no. Oh gosh, I can't subtract 214 from 92. What's gone wrong with me? Subtract 100 from 214 and then add 8. Yeah, 100. Yeah, okay. 122 terms. It's quite a lot of terms. I suppose each one has got coefficient at least 2, because everything's got coefficient at least 2 in this world. And then the coefficient of x would have to be quite big, because there's 122 terms, and they've all got coefficient at least 2. They're all positive whole numbers, the coefficients of x. But on the right hand side, it's only 214. So there's a different approach, where instead of pointing out that the number 214 isn't a multiple of 6 enough, it's also not big enough. Good. Someone says, lol, I was joking, and I wasn't quite sure. Right, maybe that'll be MAT 2020. Shooting for 100 in the real thing. Maybe that's them. The thing with the anonymous people is we can't link your messages together, right? So if you post two things, they could be different people from the same person. Oh my goodness, someone in chat has confirmed that I've done my subtraction. Thank you so much. Do 21 take away 9? Yeah, that's 12. 4 take away 2. Yes, subtracting works like that. 122. I'm confused. Says someone. Where's it gone? Where did they go? I thought someone said I'm confused. And then it's disappeared. Oh, it's withdrawn. Okay, cool. It's different to put the function inside each other rather than multiplying them together. So this is, the notation's not amazing here. I think this means this, like that, where A has been applied like m1 times. I think I wish there were brackets around them like this. There'll be A's, because we defined up here this A notation to say A to a power means do it that many times with the brackets. So I kind of wanted to see brackets there, I suppose, so that you know that these letters written next to each other mean function application rather than multiplication. But hey, if a and b naught x is put in, then we don't need 214 to be a multiple of 6, do we? Do you believe bit naught is a positive integer? So there's kind of two versions of this question, right? Some people think 0 is not a positive integer, in which case they don't let you do b naught x. That's not a positive integer to those people. They say, no, b has to, all the n numbers have to be at least 1, and all the m numbers also have to be at least 1, so all these coefficients are multiple of 6. Oh dear. But some people, I think you, and maybe me included, believe that positive integers include 0. And then you've got more work to do, unfortunately, because you're right that if you're allowed 0, then it's not true that the coefficients have to be multiples of 6. So it's not true that the right-hand side coefficient would have to be a multiple of 6. This is a case where deciding whether 0 is positive or not affects what the question means. And I wish they specified for the question. Never mind. 0 is not a positive integer in a natural number. Goodness me. Chat, debate. 0 doesn't actually help, it turns out. So it doesn't affect the truth of the statement because of the 122 kind of argument. That there have got to be a lot of terms on the left-hand side. Or would you like a different argument, I suppose, as well? A different argument is that each of the terms on the left is a combination of A's and B's. That combination we just proved, the coefficient is 1 less than the constant is 1 less than the coefficient at the top. So we can infer how many terms there are by looking at the difference between 214 and 92. This is actually the sum I just did, but with positive numbers instead of negative numbers. The difference, the discrepancy between the coefficient of x and the constant must be coming from how many terms there are adding together. Each one loses 1. I've realised I was a bit stupid earlier. I'll show you why. I was really worried in step 3 about whether these would give the same f or not when you rearrange them. I was really worried that these things might be different when you have AB and BA in a different order. That was a bit stupid of me, because the very first thing we did was to prove that they're the same thing. AB is the same thing as BA. It says that the order doesn't matter. That's the first thing we did. And also, when we did it, I said out loud, we should try and remember that for later. And then I forgot later on. I forgot. So I was really worried around here somewhere. I was really worried that these things would be different, but they're the same. Yep, people are arguing about 0. Minus k. I've plugged in x equals -1. Yeah, it's weird that it's minus k. I knew I wasn't explaining that well. -1 is cool. Let's redo that bit really quickly. -1 is cool because a of -1 is equal to -2 plus 1 is -1, and b of -1 is equal to -3 plus 2 is -1. So that means that like a of b of a of a of b of a of a of b of -1. I know I've done the wrong number of brackets. That's also -1, because the SBs don't do anything to -1. Let's give back the -1. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, eraser. So it's the same me to do the joke about how I don't care that I've got the wrong number. There we go, and then fix it. But then also get it wrong on the way. Right, good. Okay, good. Okay, it doesn't matter what you combine together, you always get -1 out of that. That's true for each of the terms on the left-hand side. So this first time here, this is some combination of A's and B's. I know that when I plug in -1, I'm going to get -1. -1 in, -1 out. Same thing over here, this is -1 in, -1 out. Same thing over here, -1 in, -1 out. How many terms are there? It's crucial to work out how to add together all these -1s. There are k terms. This is the first term, this is the second term, third term, fourth term, kth term in here. You can tell by the little subscript being k. That's how this sequence works. There are k terms. That's why the left-hand side, when you plug in -1, you get -k. On the right-hand side, when I plug in -1, I've just got to do some subtraction, and that took me much longer because I'm bad at subtracting. But it revealed how many terms there are. A bit weird. Good. Okay. I love that we found different approaches to this so far. Ooh, who's the best mathematician at Oxford? Ooh, it's a controversial question, isn't it? I can't say anything that will make everyone happy. Quinn, while I'm in charge of math, we will specify whether we mean 0 or not. Right, good, okay. I think this is better. Somebody said it's their favourite, which I'm going to extrapolate to. We all love this. I think this is pretty good. I love the way that... I wish I'd spotted it live. I've done this question before as well, so it's bad that I didn't spot it. But this thing at the top is helpful later on. It's like genuinely good. The substitution, because we've got time, I'm going to talk about the substitution. SV suggested it in chat. If you do a substitution that translates the number line around, if you move the number line around, then I guess what you can end up doing is you can end up doing a version of this question where you're working with different functions. So you translate the number line, everything's a bit weird. You've done a substitution. You're using different letters, but I'm going to write it out with the same letters. The question is much easier if a of x is 2 and b of x is 3, 3 times x, 2 times x and 3 times x. The question's easy if these are your functions, because then you know what happens when you apply them lots of times. You get powers of 2 and powers of 3. Things multiply together. Someone said, makes sense now, thank you, which is the best thing anyone says in, maybe not the best thing, but let's not exaggerate. Stream would be nothing without exaggeration. Okay, here's another math question. This one's in the thumbnail, so we have to do it. Otherwise, the live stream counts as clickbait. Here at the University of Oxford, we do not do clickbait. Although I did take the opportunity to make the thumbnail say a harder question than the actual math question. Because I thought that would be acceptable. Anyway, the actual math question just wants us to work out, just wants us to work out the coefficient of x cubed y to the 5 in this expression. You know the binomial expansion for something with 2 things inside? There is such a thing as the trinomial expansion. that's a thing. I definitely don't expect you to have seen it. Goodness me. If you've seen the trinomial expansion, then you've seen a lot of mathematics. Also, the question itself is sort of getting you to work out the main idea in the trinomial expansion, and that's more impressive to me. It's more interesting to be able to work out how the trinomial expansion, never heard of it, but try and work out how the trinomial expansion would work if it was a thing, rather than just recalling how it works. Was the answer to part V? Oh, the answer to part V was no. That's not possible, because the numbers are too different. Also differently because the numbers are not multiple of 6-ish enough. Choice to make the thumbnail harder was not actually acceptable. Does that count as unacceptable clickbait? Okay, right, good, noted. Learning how to YouTube, learning about YouTube. If you clicked on this video because you thought the thumbnail problem was hard and now you're surprised to find out the question is actually easier, then you are entitled to an apology, and I'm sorry. Good, right, let's do a poll. There's a vote in chat already, Phil. I've got to switch on the right poll. Does the trinomial expansion use Pascal's pyramid instead of Pascal's triangle? Gosh, I think it does. Yes, Pascal's pyramid. What is that though? How would that work? James' apology video. Right, okay, while you're voting and attempting this question, I will do the apology video. Sad music plays. I've obviously been crying. I've got myself ready for this. I want to apologise for the thumbnail in the video that I'm currently in. I let you down, and I tricked you into thinking that we were going to expand this entire polynomial. That was not fair, because we're in fact only going to work out one of its terms, and if I know you, chat, you're not going to work out any of the terms. You're going to do something slightly off topic that means you don't work out any of the terms. And I should have known that. I should be more honest with my thumbnail design. In my defence, and it always turns into this in my defence, there's always like a little stab of not quite contrite apology. In my defence, we did go on to expand the thing with the trinomial expansion after we'd done the MAT question later on in the video. But due to the linear nature of time, nobody's seen that at the time of this apology video. Good, right, good. Do you reckon we could get cancelled? I don't think it's a competition. Oh yeah, there needs to be a dog. Yes, Kai's right. Good, right, okay. More than fair, right, okay. I've got someone professional in chat who says it's okay. Right, okay, that segment was long enough for not that many people to do the question, but I'm not extending it, don't worry, we're going to start talking. This question's really hard, even without the thumbnail nonsense. I've seen people just get really worked up about this. There's a hint on screen, which is one approach, which makes it into the binomial expansion, right? If you squint until that xy plus y squared looks like one blob, it's a binomial because there's only two things inside. If you put brackets around, if you're strategic with your brackets, there's two things inside, and you can binomial it like that. I've seen people try and do it by binomial expanding on the first two terms paired plus the second like that. That's a lot of work. So it's quite hard to know when you're splitting it up with the binomial expansion how to do that. Addition's commutative, so there's actually other possibilities for you to consider where you maybe you want to pair up those terms, 1 plus y squared, and expand that one. And these are all options. I've thought of several sort of not in the spirit of the question ways to do this, and I wonder if chat can get them as well. Try to experiment with other functions as well. Generating functions request in chat. 5 is 3 plus 2, says somebody in chat. I'm reading out the chat messages because behind the scenes you can't see them on screen, not recorded. Denim's got a suggestion which I really like. Try n equals small values. And this is a profitable approach, because if you set n equals 1, then you don't have to do any expanding. You just write down 1 plus xy plus y squared. People who like the thumbnail, I've now expanded it in the special case that n equals 1. And then the coefficient of x cubed y to the 5. What are you talking about, mate? There's a 0 coefficient. No x cubed y to the 5 to be seen. That actually rules out options A and B, because both of those return a non-zero number when n is 1. So we've actually done sort of half the work. We only have to rule out 4 things, and we've ruled out 2 things by plugging in n equals 1. The other things are 0 up till about 3 or 4. So, we could actually work out n equals 2, plugging in n equals 2 or n equals 3. Someone says, help, I'm so lost, but it's okay, because we're going to see a proper method to do this question at the moment. At the moment, we're just messing around in the shallow end of plugging in very, very small numbers of n, trying to avoid doing any expanding. Some ideas. Subbing in numbers is actually a bit of a dead end, I think. If you sub in like x equals 0, then it's a bit hard to get the coefficient back, because when you put in x equals 0, that term will vanish, and also a whole bunch of other terms will vanish. If you plug in x equals 1, y equals 1, then that term that we're looking for will be 1, x cubed y to the 5 will be 1, but unfortunately loads of other stuff will be 1 as well. The term that's like x squared y cubed, if that term exists, will look like it doesn't. If x squared y to the 4, that term will also be 1 when you plug in x equals 1, y equals 1. So plugging in numbers for x and y is somehow not a good strategy for this question. It's something we like doing. We did it on the graph question. It was my takeaway for the graph question earlier, that I should think about plugging in numbers for x and y. Plugging in values of n is pretty good. Plugging n equals 1, 2, 3, I think the question falls apart. Or maybe we need to plug in n equals 4 as well. At that stage you're doing a lot of multiplying out, if that's your plan. There's a choosy way to do this question. And I've got a demo for how it works. So if this makes no sense to you so far, I'm going to try and ramp back down and then ramp back up again. Okay, we're going to get there. Yep, suggestions in chat behind the scenes, by the way, that you don't have to expand too far. You can maybe see that these ones are no hope for the sort of term we're looking for, but then n equals 4 does give something like x to the cube, x cubed, y to the 5. You finally get terms like the sum of these powers is 8. That's relevant. This is a bit cheaty, not cheating, like you're not actually cheating in a test, but you're avoiding doing the question in a sort of very difficult way. We're plugging in, so n equals 4 maybe does work, and then that makes you suspicious the answer might be D, because that one is non-zero when you plug in n equals 4. It gives you the number 4 when n equals 4, in a rather pleasing way. 4 times 4 choose 4 is 4. Quite like that. Right, cool. Let's do the question, I suppose, in a sort of trinomial way. So I'm going to ramp down, and I'm going to ramp back up again. Here's the ramp down. I think at school, some people learn this method for multiplying out brackets. I need some polynomials or something. Let's just put like 1 plus x and 2 plus x or something. Some people learn this method for multiplying out brackets, which is first, outside, inside, last, which spells FOIL. So some people learn this FOIL method. First, outside, inside, last, which gives me 1 times 2, it's my f. Outside, 1 times x. Inside, x times 2. Last, x squared. And then I can go simplify out something. But I've learnt this FOIL. Yeah, and the punchline that I'm going to steal from Denim's way of phrasing this. Let's switch off the poll quickly. The poll will come back in a second. People in chat like FOIL. I'll steal Denim's phrase. FOIL is choosing in disguise. This is the combinations of choices. When you work through these 4 possibilities, you're working through each choice of something from the first bracket and something from the second bracket. That's another way to imagine it, or another way to remember it. I don't have an acronym for that one. I don't have a word like FOIL. But that's kind of what's going on, right? You have the first one as being, the first number here, this 1 has been combined, the first term, I suppose, this 1 has been combined with each of the things. And this x has also been combined with each of the things. Each combination of choices. If you need to multiply together more brackets, so if we needed to do 1 plus x times 2 plus x times 3 plus x, then we could go and sort of FOIL our way through. We could FOIL on the first thing, and then we've got a lot of terms actually, because we've got a quadratic to deal with at some point. This other approach where you think about 8 things on the right hand side that come from all of the possible choices. So like how FOIL works through all of the possibilities of what's going on, and it works through them by first holding this one constant and working through the other things in the second bracket, we can do something similar by working through all the possibilities for what's going on the right-hand side. So first, if I take the first thing in each bracket, I get 6, and I'm going to get a lot of things. Because my next choice is maybe I could take the first thing, and then this x, that's my next choice. I would get 1 times 2 times x, which is 2x. And then maybe I could do first thing, second thing, first thing, which is 3x. Oh my goodness, I've sort of hard committed now. Sorry chat if this has become obvious, I'm really sorry, but I've sort of committed to the bit and have to keep going. I'm going to keep working through on x squared, and then after that one I'm going to move the first bracket, move the first slider and work my way through on the other terms as well. This has become too obvious, hasn't it? I should have picked an easier sum to do. 2x squared plus 3x squared plus, oh my goodness, xx3 or xxx, it's x cubed. And finally ending up by thinking about multiplying all the x's together. Working through all of the possibilities. There were 8 terms there because t cubed is 8. And then I can go simplify the right hand side. And this way of working through all the possibilities works not just for 3 brackets with 2 things each, but it works whenever you're multiplying brackets together. So in particular, for things like 1 plus xy plus y squared times 1 plus xy plus y squared, I like to work kind of logically. I don't always do it like this, I have to admit. But if I'm really concentrating and I really need to get the right answer, I like to work through systematically through those terms. There are going to be 9 because I've got 3 choices for things in the first bracket and I've got 3 choices for things in the second bracket. So as I work through, I'm going to pick up these 9 different terms from multiplying different choices of which thing to put together. This is an instructive thing to do because it's how the entire question works. Plus I'm starting a new line, and then I've got my y squared terms, xy cubed plus y to the 4. Okay. So that's how the whole question works, because once I've understood this, I can see that, oh, what I'm really doing is thinking about ways to choose terms from these n brackets. So I'm sort of imagining in my head n brackets, n copies of these. That's not my best drawing, but like n of these brackets. I need to pick and choose terms, picking a thing from each bracket to try and I'm trying to make x cubed y to the 5. How do I do that, and how many different ways are there to do that? Okay, that's the choosing approach, if you want to think about choices. I hope you can see that to make x cubed y to the 5, I'm going to need xy cubed in order to get, all the things I'm going to get are going to involve xy's and they're going to involve y squares. I'm going to need xy. I'm going to need 3 of those so that I get enough x's, and I'm going to need a y squared as well. So I need 3 of the xy's and 1 of the y squareds. Okay, Nikita Mazpin, I'm going to read your comment now. We must have a y squared and 3 xy's. So the y squared is the power of 1 and the xy is the power of 3, and the 1 is the power of n minus 4. So that means the coefficient is, and then there's an argument for what the coefficient is from those choices. Nikita Mazpin there has written down a trinomial coefficient. I'm not sure if they know that they've written down a trinomial coefficient, but here's the logic. My goodness. We're going to make some choices. We're going to pick some things out, and some of the order doesn't matter because we're just pointing at things to choose which of these brackets shall I pick an x, y from. Doesn't matter which ones I point at. This is a classic combinatorics thing. Nina's saying thank you to Prisma for a personal statement thing. Good. Okay. So we've got some choices to do. I actually have 2 approaches for this, for the choices. One is Nikita Mazpin's way, where you write down n factorial and you divide it. You think about all the possible choices. There are quite a lot, I think, and then you pick out which ones you want, and divide down. I have this other way, which gives me this answer more directly, I think, which chat did get right. The answer is going to turn out to be D. Should I get that? Let's have a quick look at the voting for 24.1G. Ooh, chat 74%. C and A are quite popular as well. Okay. Got to think about C. I think people pick because it's something familiar from the binomial expansion thing, where you get that n coefficient. C, I can kind of see how you get there because you want 3 of these to be xy's, which feels like choosing 3 from n. The way I think about it is as follows. I'm going to multiply out these n brackets. Four of the brackets. Most of them I'm going to pick one, but 4 of them I'm going to not pick one. 4 of them don't pick one. Don't pick one when I'm doing my choices. And I have 4 special brackets. Well, whoa, you picked a lot of 1s there, buddy. But 4 of them, don't pick a 1. Get ready. 3 of those are going to be xy's and 1 of them is going to be a y squared. I haven't told you which ones yet, but just these 4. Pick them out. Those 4 are going to be special. Well, you're not going to pick the 1 from the bracket. Okay. There are n choose 4 ways of doing that. Slightly weird step of separating out the brackets. Thinking in your mind, well, which 4 do I feel like choosing something that's not a 1? And then out of those 4, so these are my VIP, special access. These brackets, very important. I've decided that I'm not going to choose the 1 from there. I'm going to choose maybe the xy or maybe the y squared. I need to get it right though. I need to choose 3 xy's and 1 y squared. Out of those 4, choose 1 to be extra special. This is the extra special lucky one, where I will pick the y squared. Y squared. Oh my goodness. There are 4 choose 1 ways to do that. 4 choose 1 ways to choose from my VIP section which one is the best. That bracket, well, I'm going to choose the y squared from that one. I feel like choosing it from that one. The other 3, I'll pick up the xy's, and all the other millions of brackets, I'll choose the 1. Each of those choices gives me the term x cubed y to the 5, so this number of choices gives me the coefficient. My goodness. Question about the stacking thing. This notation is the same thing as NCR, which you might be more familiar with. Some people write that lower NCR down there, with the n downstairs, subscript. I prefer the bracket stacking thing, I think, which is why I've used that one. Okay. Oh, a question about graduate entry has appeared. I think we probably judge it case by case. So the applications come in. I think we probably look at it case by case. You could ask the graduate studies inbox if you like. There's an email for graduate applications. It's a bit of a mad way to explain this question with my VIP club, right? Selecting 4. So this is my justification for the answer to be n choose 4 multiplied by 4 choose 1. First choose 4 brackets where you're not selecting a 1. You've got a feeling about these ones, and then choose one of those to be extra special. I think I've done a lot of combinatorics problems where you're making choices within choices, and that's kind of what's going on here, right? That we're doing a choice and then an extra level of choosing. So when you're choosing sort of 2 sorts of things, so like first choose, you need to choose your football team, but also choose a captain, and your captain's got to be on the team or something like that. And one way to do it is like first pick your football team and then choose from the team who's the captain. Which is maybe easier to think about than trying to select a captain and then 10 other players, but don't forget that, anyway. There's got choices within choices, right? Which is a pretty natural thing to come up with. Good. It turned out to be simple. It turned out to be this one, which you can get by plugging in small values of n. I think, have you got other approaches? I haven't been looking at chat that closely. I was thinking of top 2. That's never happened. One of them is telling me the live stream is frozen, and one of them is support for Prisma. That's pretty good. Okay. PSA and also appreciation. Trinomial expansion we didn't really talk about, but it's this thing about imagining. So the binomial expansion is talking about choices. It's talking about ones you've selected and ones you have not selected. And then shuffle those up because it doesn't matter what order you picked them in. So it's like n factorial for lay these things out, put them in an order, and then divide by r factorial because it doesn't matter what order your r things are in, and divide by n minus r factorial because it doesn't matter what order the things you didn't choose in. The trinomial expansion is the same idea except with 3 buckets instead of 2. So you write out your n things. There are n factorial ways to list them. These are the things. There are n factorial ways to list them, but then divide by. I need to tell you how big the buckets are, right? Divide by a factorial, b factorial, and c factorial, where a, b, and c are the size of the buckets. A plus b plus c has to be n. You've got to put everything in one of these buckets. That's why there's 3 buckets. not 4. Anyway, this is the same idea, but just with 3 buckets instead of 2. Instead of having things you chose and things you didn't choose, you have 3 categories. Things you didn't choose, things that are on the football team but are not the captain, and the captain on the football team. Those 3 different categories. Here we've got ones where we chose 1, ones where we chose x, y, and ones where we chose y squared. So this trinomial expansion, the idea is this way of choosing things. It comes up in the coefficient, the normal expansion. This is a bit of a weird way to meet it. The normal place to meet the trinomial expansion is in the expansion of 1 plus x plus y to the power of n. Goodness me. Which is inherently about choosing how many 1s you want, how many x's you want, how many y's you want. The coefficient of x to the b, y to the c would be n factorial over a factorial, b factorial, c factorial, where n is n minus b minus c. Goodness me. Why was I multiplying that n choose 4 by 4? Well, you see, it wasn't just picking 4 brackets. Choosing the 4 brackets, where I would do a non-boring thing, not just pick the 1, that was the first step. Out of those 4 brackets, I need to decide, maybe it's the first 4 brackets. Maybe it's the first 4 brackets. I need to pick, out of these, am I going to use the y squared that's in the first bracket over here, or am I going to use the y squared that's here, or the one that's here, or the one that's here? And then I'll pick the x, y's from the other 3 brackets. If you like, when you put in n equals 4, you don't get 1, you get 4. Because there are, when you multiply this out, 4 different ways to get y squared, x, y, x, y, x, y. The y squared could be from the first bracket, the second, third, or fourth. 4 choose 1, because there's 4 and I'm choosing one of them. This is a slightly silly way to write the number 4, but, you'd imagine it being a bit more fun. What? There's a question in chat. Anyway, how do you know 4 brackets? Because I've decided that I want the only way to make, and this is an important observation I suppose, the only way to make x cubed y to the 5, the thing they're asking us about, the only way to make that is to have 3 xy's and 1 y squared. There are other versions of this question which are harder. Would you like to see them? Oh. It doesn't matter if you say mathematics or maths in your personal statement, that is fine with me. Either way, maths is fewer characters. You do not get judged by Oxford for saying maths, if that's what you're thinking. Despite that, my sixth form told me that I should say mathematics with a capital M and the whole word mathematics. So that's what I did, and I used some of my vital characters on writing mathematics with a capital M. If you would like to see the rest of the disaster that is my personal statement, it is on this YouTube channel. Good. Being confused, I think it's cool. It's quite good, isn't it? Okay, so hard version of the question. Nobody voted for yes. Oh no, Harriet did. Everyone blame Harriet. Don't blame Harriet. Right? Okay. It's just a nice live stream. Gotta be careful not to suddenly make it a not nice live stream. Harriet's great. Anybody else? Just Harriet and me. Right. Good. Okay. So harder version of this question would be something like 1 plus x squared to the power of n, coefficient of x to the 5 or something. This is hard because you can make x to the 5 by, well, you tell me, you can make x to the 5 in different ways, several different ways. So we need to allow for lots of different things that happen. I've spelled coefficient almost right, but I haven't really tried with some of the letters. You will not be judged for saying math either. We might think that you're American, but I understand that some Europeans say math as well, so I'd be wrong to assume that, wouldn't I? Yes, judge anyway. Is that why you only got it? The worst thing is, I don't even know which specific thing they're referring to. There are so many. I did something stupid, and this person wants me to know. Leo wants to see this too. Good. Oh, Raphael, is that code that... Raphael, put some code. Vet the code. I think it's the question that I posed about an hour ago. I don't have to run this. Oh, it's not looking good for the random one. Raphael, I'm improving it. Some GitHub code that... GitHub code that I think... Yeah. Oh, look, there are GitHub links to this particular website that we're on. Sorry, this is the answer to an old question from about an hour ago in this same video, but because of live stream, we can get the answer in the same video. Raphael did some simulations. I think these are simulations. Mean calculation. Or is it an actual calculation? Let us know in chat. Is that a sim or a coding it the whole time? Is it a sim or is it calculation? Either's possible. Okay, good. Inspired by the video I'm currently in. Let's not open it because that'll do a sort of loop. It's a simulation with a million. Cool, right. Good homework attempt. Outstanding homework is the version where the horrible version where you calculate. You tick 10 boxes on the MAT multiple choice grid at random. What's the expected score? Good. Why do you write m equals mathematics and say m for the rest of your statement? This is so problematic because I'm clearly amused, right? I think this is funny. I do not think you should do it, but I can't quite explain why. Right, please don't write your personal statement trying to make me laugh. I might not be the person reviewing your personal statement. Oh, right, sorry, serious maths question. Oh, look, an actual suggestion in chat. I'd forgotten we had a question on the board. We've got a question on the board, and somebody's had a go at it. Carl Frederick Gauss has reminded me of a question here that there's a question that I saw at a maths summer school once, which is if you assume that words are equal to each other if they sound the same. So like pair, P-E-A-R, and pair, P-A-I-R, sound the same. If you assume that words are equal if they sound the same, you're not allowed to permute the letters, but you can cancel off letters on the front and the back, on the end. You can't assume it's commutative, but can you prove that all letters are equal to each other? Right, cool. That is a daft statement. Somebody pointed out that Gauss might have divided by 0. So be careful with that one. Right, cool. This is the. I don't think there's any other live stream chat quite like this one. Right, good. Okay. Coverage note is 5. 3 different things to worry about. One is that this x might be raised to the power of 5. One is that this x squared might get involved, and then the other one is that it might get involved some more. We might have x squared, or we might have x squared like that. And you can make this question kind of arbitrarily hard for yourself if you like. A fun way to make it difficult is to put numbers inside. So if you try the question but with a 2 in here, then everything's much worse because you've got to allow for all the powers of 2 that come out. Write that in, and yes. I can't take credit for it, but I think it is a result that if you allow different accents for words that sound the same, you need to stretch a little bit to what is and what isn't a homophone, but you can prove that all the letters are equal to each other by just reducing things down. Like that pair example, the P's and R's are irrelevant, but it proves that EA is the same thing as AI. That might be useful in other words when you're trying to prove equivalences down the road. Yeah. So AI is equal to EA because you can cancel off the P's and you can cancel off the R's. Let's not permute the letters. That makes it too easy. But cancel off the front and the back. Right, good times. Am I at the open days tomorrow? Yes, very much so. Yeah, doing some maths talks. What's a good stock response to the when will I ever use this IRL about maths? I have to be careful now because there's a Saturday morning breakfast cartoon with a really funny answer, but it's a bit inappropriately funny. I think that more than ever before, we have very little idea what is going to happen in the future. I don't know if you feel this too, but I already felt this was like the way tech was going before all the weird stuff. Basically no idea what's going on in the future. I have this kind of personal belief that telling the younger people about mathematics might be helpful. I've just got this feeling that maths might turn out to be handy for the sort of challenges that they're going to face down the road. And I might be wrong. It's a gamble. It's the future. I don't know. But maybe you've got this opinion too, that the challenges coming up in the future might be approached by knowing how to solve complex problems and work with complex things. Of course, we might all be wrong. This might be completely useless. But hey, we're really good at it, so let's not stop now. I've got a little bit behind with chat. What's chat going Did we forget about poor little 2040 question 1A? No, we're doing it. We've only got 10 minutes. Where did the time go? We were really ahead of time and then suddenly got distracted by trinomial expansions. Nobody forgot about 2014 question 1A, just because it's a question 1A, which I've sometimes described as intentionally slightly too easy. Not slightly too, no I haven't. I've never said that, that's overstating it. It's an inequality question. Good old inequalities. It's secretly a quadratic. You can tell because of the even powers. More than that, the power of 4 and the power of 2. It's not secretly a quadratic. Hang on. It is a bit similar to the a to the 4 minus a squared problem that I set about an hour and a half ago, and people thought about. Let's do that one on the side. So the question was a to the 4 minus a squared, and I told you that a is somewhere between minus 2 and 1. And I guess the challenge is to try and draw that graph. The challenge for coming at this question was trying to draw the graph without drawing it, because if I draw it, you've all seen it. I have to draw it in my head. So this is why we're interested in research on aphantasia, right? I had to try and put that in my head, but without drawing it, so that you couldn't see it. So then the question is, where are these points where it's 0? I guess a to the 4 is equal to a squared when a is 0, or when a is 1. And that's minus 1. There's 1. And then minus 2 is way over here somewhere. Okay. So the function is extremely positive over there, and the maximum we're going to see is when a is negative 2, and we're going to get minus 2 to the power of 4 is 2, 4, 8, 16. Take off the 4, we get 12. So I think we can say that a to the 4 minus a squared is less than 12. Way over there, minus 2 is kind of like a frayed end of string. It's the b is not included, so it's going to have like a open-ended bit over there. But there's this minimum as well. We can find the minimum of a function like this by differentiating it. If we differentiate it, we get something like this. 2a, come on, I can do this. Which is the minimum when a squared is equal to 1/2. If a squared is 1/2, then this is a quarter minus 1/2 is minus 1/2. So this minimum happens at a value of minus 1/4 over here. So we can actually say that this is less than or equal to minus 1/4, because it actually attains that. It actually attains that bound going through the minimum. It comes in and actually gets there. It's like a piece of string that's been folded over 3 times, and it has a frayed end at the top, and it's been folded over into a W shape, and then there's a frayed end that doesn't matter, and at the bottom it actually attains that bit. So I saw lots of people saying that minus 1/4 and 12, but not everybody says something about having the less than or equal to sign in there as well. That seems unlikely. Let me check that very quickly. Oh my goodness, it's actually a real thing. Huh, right, cool. Yeah, you can have that. Cool. Behind the poll, how's the poll going? Oh, we haven't started the question yet. I did a different question. Poll going well. Somebody just linked to, it's Nicky has linked to a trinomial theorem video by Black Pepper and Pen. Is there a error in the revision? That sounds likely. NCR, should it be x to the m minus r, y to the r in revision? Okay, don't stop thinking about this question. I'm just going to quickly check my revision material for an error that's been there for years. Oh no, this is allowed, right? This is okay. This is not an error. This is a misunderstanding. I'm expanding left to right, you're expanding right to left, it's fine. N choose r is the same thing as n choose m minus r. So this is fine, I think. You're thinking about the term that's symmetrically opposite, but has weirdly the same coefficient, because the binomial coefficients are symmetric. No, you can do maths, it's fine. They've said in chat they can't do maths, but they can. It was not impossible that there was a mistake, and it was much easier to just point out the mistake rather than try to work out what on earth James means. You can waste a lot of time trying to work out what James means. Right, should we do this question, just to wrap up then? It's about 5 to 7. Then it's dinner time for me. Maybe it's dinner time. It depends when you're watching. Right, cool. I'm going a bit silly. It's definitely time to think about wrapping this up. Let's solve this inequality. 2 approaches, I think. One is to think of it as a quadratic of x squared, and the other one maybe is just draw a graph. Think about some graphs. Other ones, graphs we be familiar with. I love these, like polynomials. People aren't familiar enough, I think, with polynomials. You know about polynomials. We've got an episode next week about polynomials. What do they look like? Sketch a few. Can you draw different cases for different things going on? I've thought about this one enough that I can draw it, as I just said, draw it without drawing it, by imagining it. We should do this question on the board. Good. What was the answer to trinomial? Oh yeah, sorry. It was the thing someone said in chat. They were correct. It was good. And they didn't read it out, which was rude of me. Right, we're going to do this. We're going to answer the trinomial. I'm going to answer this thing. If you introduce yourself as Mames Junro, I will sign your calculator. Right, good. Okay, let's go. I am aware that I say, right, yeah, let's go too much. I think this factorises. Does this factorise? I really want it to factorise. Oh yeah, it factorises. I'm working upwards, which is non-standard. Plus 1? Plus 1. Minus 9x squared. Yeah. Okay, this term looks strongly positive. Strongly positive? It just looks positive. It's non-zero as well. Strictly positive, that's the word. This is strictly positive. It's definitely positive, so I'm not worried about that bit. I want this to be negative. When is that thing negative? Well, it's x squared, but shifted down a bit. It's negative between minus 3 and 3. So I think that means the answer is A. How did chat do? I can't find out how chat did. It's gone terribly. No, it's gone brilliantly. 97%. Yes, chat. Oh, 97%. That's brilliant. One vote for B. How do you get B? I don't know how you get B. I think they mistapped. Tapped the wrong one. It was right next to it. Challenge trinomial. We didn't do the challenge trinomial question. Right, cool. 3 minutes. Okay, good. About time to stop doing this one now. Somebody's posted a borderline comment, and then they've also posted, I know you're thinking about whether or not to. Yeah, there it is. I know you're ethically confused about whether to put this slightly borderline joke in chat. Right, cool. Let's wrap this up by doing this question. Coverage of the base of the 5. So, I need to think, maybe we just pick 5 of the terms to be where we choose maybe we just choose 5 of them, and then we're done. We pick 5 of them, those are the ones where we pick the x. Brilliant. No sub-choosing thing necessary, just pick 5 of them, choose the x from each of those, just like we would for the binomial expansion. Forget about the x squares. You don't have to use them if you don't want to when you do the multiplication out. You could just choose never to pick the x squared. Okay, it's one source of term. Or you could engage with the x squared terms. You could choose, so what would this be? This would be 3, with my way of doing this is choosing 1, 2, 3, 4 different special terms, and out of those 4, choosing one of them in particular to be the x squared, the one where you choose x squared. You double up, pick the x squared from that one. And then over here, I think this will be, you want to choose 3 special brackets. Oops, excuse me. 3 special brackets, and you want then to choose one of them out of those 3 to be this x to the 1 thing, and the other 2 will be x squareds. So that gives me something like n choose 5 plus 4 times n choose 4 plus 3 times n choose 3. Which makes me think, could I have done this differently? And the answer is yes, I could have done this differently. I could have thought about, the first time I want to think about is n choose 5, that method. This one, I could think about choosing an x squared from one of the brackets. There are n choices where I could choose that x squared bracket. And then choosing from the remaining 1 plus x plus x squared to the power of n minus 2, just choosing n minus 2 from the n minus 2s, making sure that I choose 3 of them from that. Does that work? I think that works. N choices first, and then from the remaining n minus 2, I want n minus 1 here. Don't like this method so much, it's making me get the wrong answer. Good, cool. Other things. Has the 22 paper been written yet? Yes. It's good. Oh, I did get approved. We thought it was borderline. They did the thing that TikTok does where you put egg instead. There we go. Has it overtaken the other comment for top post? Oh, no, I think it's not. Cool. Right. First time we got so many votes for Prisma being great. Let's have a quick look at top chat. Top chat, popular. Prisma's Beth mentioned Oxford, like if you agree. All the ones that say like if you agree did quite well. Livestream froze. Half as popular as Prisma. This joke that's just happened anonymously. E from Overflow Error is pretty funny. I liked that. The countdown's getting votes. Oh no. Oh yeah, no, it's a joke. There's the. I think I sort of got on. Yeah, good. This was too fun. Good, right, and the 20% chance. That was a good moment. How many great moments we've had in the last 2 hours? Great moments. Does anyone want full marks in math? Yeah, occasionally. Yeah, there's a bit where you explained emoji to me. And then I tried to do one. Right, cool. Will I take a photo of Nikita Masbin wearing Hassatai? You got kicked out of the team, mate. You're not on anymore. It's not happening. We're going to wrap up because it's 7 o'clock. Thank you very much for watching this bit of a mess of a live event that we run every week. If you want to watch the previous ones, they're on this YouTube channel and this website, depending on where you're watching this. If you want to watch the future ones, we haven't made them yet, but if you join us live on Thursdays at 5 o'clock for the next month or so, we're putting out more MAT live streams, and we will see you there. What about 4 terms expansions? What the phrase? Make up your own phrase, and then Google it to see if anybody else has made up that phrase as well. Other search engines are available. Good, right, okay, take care everyone. Let's go. Thank you, Prisma, for moderating. Good. Right, okay. Just checking chat. Good, right, cool. Nobody wants to point out any more typos. I think we got one very genuine typo in Thanks Denim 2009. I made a note. I have a little post-it. See the post-it you like. This is what happens when someone in the live stream tells me something and I'm like, I cannot fix this live, but I need to go and make sure to go and do it. Look, I've got this 2009. Who knows if that'll get fixed anytime soon, but we'll find out. Right, cool. That's all. And then I need to turn off the live stream, and I'm going to actually turn it off this time. Last week, bit of a disaster. We don't talk about last week. Bye.